If we're given a derivative function and we're asked to find the original function, then we take the integral or the antiderivative to go back to the original function. But we have to add a plus c to it. Now, if I'm given some point on the original function, some x, y, some coordinates, then I can plug those values into my original function and solve for c and actually have the original function. So in this video, I'm going to find the constant of integration c. So I'm going to jump into some examples. These examples are from the Haish Math book. Let's just look at number 1 to start out with. So I have my derivative function of 2x minus 1, and I want to go back to the original function. So we take the integral. So to get back to my original function, we take the integral. That's going to give me 2x squared over 2 minus x plus c. Now, since we're given some point on the original function, this is my x value, this is my y value, my coordinates is 0, 3. I'm going to plug these values in and solve for c. So that gives me 3 equals, these cancel out, so that would give me 0 squared minus 0 plus c. And of course, 0 squared is 0, minus 0 is 0, and so we're left with 3 equals c. So my original function then is f of x equals x squared minus x plus 3. Right, let's look at another problem. Let's look at this one here. We want to go back to the original function, so we're going to take the integral, so I have 3x cubed over 3 plus 2x squared over 2 plus c. We take our x, y values, plug them in. Let's cancel some things out first. And that would give us 5 equals 2 cubed. We should use, it doesn't really matter because it's positive, but we should use placeholders anyway. I think it's helpful. Plus 2 squared plus c. And 2 cubed, that's going to give me 8 plus 2 squared, that's 4 plus c equals 5. So that gives me 5 equals 8 plus 4 is 12 plus c. We subtract the 12 from both sides. That gives us negative 7 equals c. And then we take that negative 7, plug it in for c, and that gives us our original function of f of x equals x cubed plus x squared, and our c value is negative 7. So this is the answer for part B. Let's do another problem, and then we'll jump down to some fun things at do some double, if we have a double derivative, and we have to work back by taking the integral twice. So let's look at the next one. I'm just going to rewrite this. I have f prime of x equals x minus 2 times x to the power of negative 1/2. And I want to go back to the original function. To go back to the original function, I'm going to take the integral, so that becomes x squared over 2 minus 2 times x to the power of, if I add 1 to negative 1/2, I get 1/2 over 1/2 plus c. We could take the reciprocal. I have a fraction divided by a fraction, so we should take the reciprocal. That would give me negative 4 here, so I have f of x equals 1/2 x squared minus 4x to the power 1/2 plus c. Take these values of x and y, plug them in, and so I have 2 equals 1/2. We plug in 1 squared minus 4 times 1 to the power 1/2 plus c. So that's going to give me what? 2 equals 1/2 minus 4 plus c. We have a fraction, so let's make everything a fraction. The 2 becomes what? 4 halves equals 1/2 minus 8 halves, that's 4, right? Plus c. That gives us 4 halves equals negative 7 halves plus c, 7 halves. And then we're going to add 7 halves to both sides. That gives us 7, 8, 9, 10, 11. We get 11 halves. So our function then, we've run out of room. Our function, I'm not going to do this part anyway, so I'm just going to write it here. We have f of x equals 1/2 x squared minus 4x to the power 1/2 plus 11 halves. So, all right, let's do something a little bit more interesting. We're going to take we have the second derivative, and in order to go back to the original function, we need to take the second integral. So we're literally taking the integral of this function of 2x plus 1 with respect to dx 2 times. So that's going to give us what we have, 2x squared over 2 plus x plus c. That's my first derivative. So for our first derivative, we need to plug in our x and y values. So that would give us 3 equals, let's cancel these out, 1 squared plus 1 plus c. And 1 squared is just 1. 1 plus 1 is 2. Subtract 2, that would give us 1. So I have c equals 1. And so my first derivative is going to be x squared plus x plus 1. Now if I want to find back to our original function, we take the integral again. And so that's going to give us x cubed over 3 plus x squared over 2 plus x plus c. And then we plug in our x, y values. So that's going to give us 7 equals 2 cubed over 3 plus 2 squared over 2 plus 2 plus c. And then we have 7 equals 2 cubed is 8. That gives us 8 thirds plus 2 squared, that's 4. 4 halves plus 2 plus c. Now we have a bunch of fractions, so we're going to have to rewrite all of these in fractions. Now the common denominator for 1 and 3 and 2 would be 6. So I'm going to multiply this fraction here by 1 in the form of 6, 6. I'm going to multiply this fraction here by 1 in the form of 2 halves. I'm going to multiply this fraction here by 3 thirds, sorry. And then this one by 6, 6. So that's going to give me 42 over 6 equals 8 times 2 is 16, 16 sixths, and then plus 12 over 6, plus 12 over 6, and then plus c. So when we add up all these, so I have this 42 sixths equals, and we'll combine all these like terms, we have 16 plus 12 plus another 12, so 16 plus 24, that would give us 34, and then 40. So I have 40 over 6 plus c. We subtract this 46 from both sides to get 2 over 6 equals c. And then, so our function then, our original function is f of x equals 1/3 x to the power of 3 plus 1/2 x squared plus x, and then plus 2 6ths is just 1/3, so we get 1/3. So there we go. That is 3a. So let's go ahead and since I've lost out some room here, let's just do one more. Let's just bump down to this. Let's do c. Let's do c. C looks fun because if we're starting with the second derivative, then to go back to the first derivative and then the original function, we're swapping back from cosine to sine and cosine, back and forth. So that's why this one looks a little bit more exciting. So first thing I'm going to do is, again, I'm trying to find the original function. So I'm going to take the integral of cosine of x, which is sine of x. So I have so my first derivative is going to be sine of x, and then plus c, of course. And then we need to plug these x and y values into our function so that we have 0 equals sine of pi halves plus c. Now sine of pi halves, if we look at our unit circle, and this is our original side here, and we're going to rotate around pi halves. So we're looking at this point here, that point here is 0, 1. Sine is our y value, so that all becomes 1. So we have 0 equals 1 plus c. We're going to subtract 1 from both sides, so c equals -1. So we have our first derivative is going to be sine of x minus 1. So now we need to find the first function, find our function, which is f of x. And the integral of sine of x is negative cosine of x. And the integral of negative 1 is negative x plus c. And then we take these x, y values and plug them in to our original function to see what we get. So we have, we plug them into our original function to solve for c. So we get 3 equals negative cosine of 0, a 0 angle, minus x plus c, minus 0 plus c. Right, where x, all of our x's are 0. So this should be 0 and this should be 0. Well, negative cosine of 0, so that would be our angle of 0. So this particular point right here is 1, 0. So for cosine, our cosine of a 0 degree is, of 0 degrees is 1. So that's going to give me 3 equals negative 1 minus 0 plus c. And I'm going to add 1 to both sides, and that should give me 4, so c equals 4. So our original function is f of x equals negative cosine of x minus x plus 4. So there you go. Hope this video was helpful, and have a wonderful day.